Hey guys, how's it going? And I am back today with another kind of tutorial base level kind of thing for you guys. Not too complicated. So today we are going to be going over how to do Armorstand animation similar to what you saw in my most recent map, which I've had a couple requests for, and just how I do it. Now there is generators online. Of course, there's generators, blah, 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 but sometimes you don't want to deal with it. You want to just do something really simple, or you just want to do it yourself, and knowing these methods can be helpful for other kind of command stuff you want to do. It's another approach. There is online generators that are probably more efficient at giving you stuff and having large commands and but they're very precise. But this is just the method that I use because it's very fast. You can do it really quickly and on the fly. So the dummy dumb method is, so I'm just pointing out the fact that in base game, when you put a block model on some entity's head, it's not the full block size, so you can't really get a good looking fake block that you're able to move using normal methods. So there's two methods. There's the Shulker and falling sand. Now this one looks really good, but it's got some weirdities like that. I just fall straight through, and actually, sorry, there should be a shulker there. So this thing has some weird stuff, like I get stuck sometimes on top, and you have to worry about 3 entities. This is a lot bigger, but I will have this in the description if you want to use it. I don't suggest using this method. It's not the best, but it is having an armor stand with an invisible shulker with a falling sand. So you're able to move the falling sand like it's a regular entity. Then the last method is a resource pack method. So there's 2 means you can do using a resource pack. You can create your own model that's a block, or let's say you have a specific thing you want to make, like I had a door in my map. So you would make the model and then you would put it on the armor stand. Boom, easy. The complicated part is just making the model and getting everything to line up just right. But this looks pretty good. Now the top is messed up because I was lazy and I wanted to use my own model rather than change the base model. Whatever, we'll go over that in a sec here. So basically the way that you make this, let's just get right into how I did that model first. Let's go into resource packs. So let's pretend you were able to make a resource pack, and I'm not going over how to make resource packs or how to make custom model data in this video. I have other videos on how to do that. So I have a custom model data on a diamond pickaxe, which says that when the custom model data is a certain number, it will show a bookshelf. And the bookshelf model is right here. Bookshelf, bookshelf, bookshelf. Here it is. I called it book underscore shelf so that it doesn't mess up the base one. And the texture it references is a bookshelf texture that makes it on 4 on all sides. Now the key thing here is scale 1.6, 1.6, 1.6. So you could use custom model data, but there is another thing you could do if you want to change the base stats of the game. But this means that anytime you put a block on an entity's head, it will no longer look like this, it will look like this. But you can change that if you go Minecraft models, block. Now in your block, what you want to do is you want to replace it with something different. So we're gonna go versions and go to our latest version. Open this with a WinRAR archiver. Let me go back to that folder. Now we can go, now the base game has models, so we can go models, block. Then we can come down to BO, BOO, BOO, BRO, BL, bookshelf. Here it is. It's hard to find because there's a lot. So now that it's copied into here, this is everything that's there, but what we need is this bit down here. You can pause if you want to copy this bit. Display, head, translation, scale. You can change translation to change the translation. For me, I wanted to make it so that the thing appears to be at the armor stand's feet, but you can mess around with that to get just the right numbers that you like to work with. If you change it to 0, then it will be in the head just like it was before. So let me get rid of this, and let me get rid of this. Now, back into the actual data pack side. So that's how you deal with the resource pack portion of it, but it's not very complicated. Now let's go to an example of Armorstand animation. So this is loop sliding, or whatever you want to call it. The point is you use a loop to slide a block backwards or in any direction. So you can see this perfect kind of sliding motion and it stops as soon as it's moved one block. All of these are going to be using the this method rather than the Shulker box method, just because this thing has a lot of glitches and issues with the block placing itself down. So I'm just using this method. So anyway, so this does the sliding. And the way that we do this, so we have this iteration counter you can see on the side. It says 10. When I click it, it counts up to 10. So let's see how exactly it's doing that. So if we go into this file that it's playing, so all that it's doing is it's playing this file right here. And it's spawning an Armorstand that has a diamond pickaxe on its head and has these tags. Not too complicated there. So in the file, it's actually pretty simple. So we add 1 to I iterations every time this file gets played. So we also, every time this file gets played, we execute as the bookshelf, that specific bookshelf at the entity, so located at it. Then we TP that entity forward in the Z direction by 0.1. Then if we have reached 10 or above, then we say done. Unless we reached 10 or above, so if the top condition doesn't work, then this condition will go, and this condition schedules the function to play one tick later. So it allows a 1 tick delay between when this function plays and when it plays again, so you can see the transition. If you don't have schedule, then it's going to do it in what's like a raycasting style loop, where it's going to do the whole loop without you ever getting a frame update. So doing schedule 1 tick makes it a little bit slower, so you can actually see the game update with the function. But the punishment for using schedule is you have to have this portion here, because every time you reschedule the function, it changes to say that the person playing the function is the world at the world origin location. So that's pretty much it. So we're going to add 1 until we reach 10. The calculation you can do to figure out how close you are to exactly what you want to do. So if you want to move one whole block, well, we have to move one whole block, and let's say we want to do it in increments of 0.1, then we need 0.1 block. 1 divided by 0.1 is equal to 10, so that's why it's 10. So let's say we wanted to change the increments to 0.2. Well, 1 divided by 0.2 is 5, so we would only need 5 iterations to do that, so we would just change this to 5. So that's pretty simple, and I will be having this data pack in the description so you can download it, but I would not suggest using it since the function namespaces are A, which is a very small letter. It's not designed for you to take and use other places. So that's how the loop sliding works. So it moves it back 1. Now this is the 2-stage loop sliding, so this is a little more practical. So first we move back, then we wait, then we move to the right. So this would simulate something like in my map where I have this going on. And then it goes boop, boop, just like that. And it's pretty much done exactly the way that I show it here. So if we go into the demo 1, there's actually going to be 2 files for this, because first we need to move back. Demo 1 is pretty much the same as the thing we just went over. We move backwards and we loop. But when it gets to the end, this is the end condition, which has to come before the loop condition. If you put this afterwards, you're going to have some problems. This has to be the done condition has to come before the loop condition. So the done condition doesn't say the word done because we're not done yet. So it's actually going to schedule demo 1B to happen half a second later or 10 ticks later. This is 10 ticks or half a second. So it does move back and then it pauses for half a second and then it moves this way. If you don't pause, then it's going to look like it's kind of going in a diagonal direction. Now 1B is this function that it's going to be scheduling. And in 1B, it's pretty much exactly the same, but we changed the TP direction to be to the right, and we just made sure that it's looping 1B instead of 1, so it's looping itself. And this time we do say done because we are done, but I did change it to, yes, I did change the number here from 10 to 20 because there's no cut in between. So this counts up to 10. Then this counts from 10 to 20. So this counts from 0 to 10, this counts from 10 to 20. So 10 to 20 is 10 iterations, which would be 1 block. So a little more confusing on what number to put here. If you want to be safe, you can make this guy play a separate function that happens before the loop begins that resets iteration to 0. So you can put iteration back to 0 and then make that function play the moving into the next stage. But I was just doing it for the sake of time. So first it moves there, then it moves there. Now I am going through this pretty fast. I'm sorry about that. Hopefully you can slow things down for yourself because it is kind of long. So the last thing is loop rotation. Loop rotation is just rotating things in a loop as opposed to moving things with TP. You can rotate with TP as well. So this is a little axe going down and swinging and chopping. Now this one is a little bit different, but it's pretty much exactly the same. So we have the end condition and the looping condition, both just like they should be, and we have the adding to the iterations, but then we have this new line instead of a TP. So what we're doing is we have this armor stand, and when he begins, his rotation is -90, so his axe is in the air. That you have to do that to make the axe in the air. So we set iteration to be -90 at the starting position, because we're going to use iteration to control the right arm rotation. So we store the results of that armor stand's pose.right arm at 0. So I got there from going pose dot, because I see the curly brace, right arm, parenthesis, bracket, because I see the bracket, end bracket, and inside it I want to pick this first number, so I do 0 because 0 is the first number. So that's how I get this path here. You can always use /data_get entity at etag equals demo2 limit equals 1, and that will bring all of his information, and then you can slowly hone in on what you want to pick. So pose will give me all this stuff. That's not exactly what I want. I want that number that's -22. So I can do dot because we have a curly brace, and I can go right arm, and now it gives me the 3 numbers. So I see the 3 choices with the bracket, so I need brackets myself, and then now I need a number to choose which one I want. 0, 1, 2, we're gonna pick 0, and we get -22F. We see an F here so that we know that after we branch to this location, we need to say that it is a float type value and that we want to keep the scale to be 1. Then we get the iteration score. So whatever number the iteration is, we are going to put that onto the float. Now you can condense this. You can put this line right here and make it less commands. Let me reopen that. But yeah, you can put this line up here and it'll work just the same, but I just split it up so that it would be easier for you to see. So I make it increment by 4 each time, because if I do by 1, -90 until -20 does not look very fast. Let me show you what increments of 1 is. And that's because we are looping 90 times, because we're going from -90, well, -90 to -20 is basically 70 iterations, right? 70 times 1 tick is 70 ticks, right? And if there is 20 ticks per 1 second, then that is 3.5 seconds for the entire thing, if I only do it in increments of 1. So 3.5 seconds to rotate the arm is kind of long, right? So I want to make it faster. So we have 3.5 seconds, so if we change that number, it will make it go faster. So I change it to 4, so 3.5 divided by 4 is going to be some number around 1. So if I change it to some number around 1, then it looks a little more reasonable. So you can change the speed, however the rotation will look more choppy. And that's just something you can do. And then this number that you stop the rotations at is just something you can tweak with to see what looks right. I just figured that -20 made the axe head inside the block and the handle not in the block, and it just looked kind of nice like that. But you can tweak those numbers. Those are all just things you can change, these numbers and these numbers here, to figure out what exact rotation you want to start at and what one you want to finish at. So that's pretty much it. That's all of them. Now I'm just going to show you a quick little thing that I put together really quickly here, because I am working on big projects as well. But I'm just going to show you a quick little animation I made that's a little more complex, but uses some of the stuff we went over. So click that. We have the giant TNT, and then after a little bit of time, boom, and it resets. So let's go over how that goes. So it takes quite a bit more, but let's see all the things involved. So we'll start at the start, and we'll work our way down. So in the start, we kill everything so that we can reset, and we spawn everything again. So when I start, I'm actually spawning things under the ground. And that's just because I don't care about people seeing under the ground. It was just the situation. It fit and made sense. So I spawned these things under the ground, and I put barriers all up here so that you can't like stand on top of this. It's blocked off because it's moving. Then I set iterations to 0 again. Then I play the main function. Main is a big loop. This is a big guy. So this adds 1 to iterations, and this loop, the end condition ends when loop is done with 120 iterations. And when it's done with 120 iterations, we're going to play the end function. But until then, we play this file every tick. Now, what happens during this file every tick? So one thing that happens every tick is that the TNT component is teleported, and it is used these two numbers to rotate it 2 in the axial, I don't know, this direction. It rotates its head like that by in increments in numbers of 2, so it's kind of slow. And then the next thing it does is if the number is between 0 and 60, we are going to play up. So you can see from this that between 0 and 60, so when it first starts, and 60, things are going to be happening from up. But when between 60 and 120, nothing's happening except for this rotation. And we'll look at the animation again real quick here just so you can see that. So initially things are moving up, and then for a little bit, nothing is happening except for this rotation. And then something happens. So that moving up is the up function, and all up does is it teleports each of the 4 fake blocks upwards. Then when it gets to the end, it summons a creeper that already is going to explode because its fuse is 0, kills all the blocks again, puts air back where it's, puts air in all these locations, and it summons the chiseled fake block just to be the starter, and it puts a oak button on here. So all that being done, we have the final short little animation of block coming out of the ground with the spinning TNT, and it explodes. So kind of complicated, took quite a while to go through everything. There's a lot more you can do with this, and I would love to see what you guys can come up with. So if you have any cool Armorstand animations besides McMacastein's giant door, go ahead and let me know, and you can post it in the creations tab on Discord, which is in the description. Other than that, guys, thanks for watching, and I'll see you in the next one. Peace.